This video explains a third sampling strategy called multi-stage sampling. Multi-stage sampling is designed to select units at the lowest level of sampling. It does this by using a separate sampling frame for each stage of sampling. For example, you could use a sampling frame of all villages in the target area as the first stage, all households within those villages as the second stage, and individuals within those households as the third stage. As you can see, this strategy may use different approaches at different stages of the sampling process. For two-stage cluster sampling, which is a common type of multi-stage sampling, the target population is divided into clusters, which are sampled, and then a second sample is selected from within the sampled cluster. A common example of this strategy is using probability proportional to size, or PPS, sampling for the first stage, say the selection of the villages, and then using simple random sampling for the second stage. We'll explain using PPS in a subsequent video. It provides a way to minimize logistical burden and cost while maintaining an unbiased sample. Multi-stage sampling is useful because it can be more practical and more cost-effective than using simple random sampling. That is especially the case when we're sampling from a large population that is geographically dispersed and would require enumerators to travel long distances. Depending on the sampling strategies used, your data may or may not be self-weighted. For example, if you use PPS as the first stage and SRS at the second stage, there is no need to apply weights. In terms of disadvantages, multi-stage sampling provides relatively less precision, since households within a cluster, say a particular village, tend to be more similar to each other than households in other clusters. This phenomenon is called intra-cluster correlation. One strategy for minimizing intra-cluster correlation is sampling more clusters with a smaller sample size for each cluster. Multi-stage sampling is typically done for large-scale data collection activities where a large area is represented. If you work on a USAID-funded resilience food security activity or a large development program with a dispersed participant population, multi-stage sampling is a great strategy for minimizing logistical burden and cost while maintaining an unbiased sample. A population-based survey will almost always require multi-stage sampling due to the size of the sampling frame. As mentioned previously, one way to limit intra-cluster correlation is to sample more clusters with a smaller sample size for each cluster. Let's say our sample size is 720, meaning we want to collect data from 720 households. Here is a list of possible cluster and sampling unit combinations we could use to reach a sample size of 720. Which of these options do you think would best limit intra-cluster correlation? Option C is best for reducing intra-cluster correlation, since it takes advantage of the most clusters. Although C is the best option for increasing precision, it does increase the logistical burden and cost, since data collectors will have to go to 40 villages rather than 30 or 36 in options A and B respectively. So, to determine the best sampling option for a specific situation, implementing partners should weigh the pros and cons of cost and rigor. Finally, here's a graphic showing the multi-stage sampling strategy.